Welcome to Across the Globe. Today we will learn about building APIs with Go. Go is a robust programming language known for its speed and simplicity, making it ideal for developing APIs. One of its key strengths is the efficient handling of HTTP requests and responses, which simplifies the process of building RESTful APIs. For example, a company may choose to use Go to construct a high-performance API backend for their e-commerce platform due to its ability to manage a high volume of HTTP requests smoothly. By leveraging Go's standard libraries for HTTP handling, developers can streamline API development and create robust and responsive services. To handle HTTP requests in Go, we define a handler function that accepts a response writer and a request. An example code snippet is provided where the handler function is defined to write "Hello World" to the response writer when a request is made to the root path /. The function http.handlefunc/handler associates the handler function with the root path, and http.listenandserve880 starts an HTTP server on port 8080 to handle incoming requests. This code sets up a basic HTTP server in Go to respond with "Hello World" when accessed through a web browser or API tool. In Go, endpoints are defined using the ht.handlefunc method, where a URL path is associated with a handler function. When a request is made to a corresponding path, the associated handler function is executed. For instance, in the provided Go example, the /hello path is mapped to the hello handler function. When a client accesses the /hello endpoint, the hello handler function is triggered, responding with "Hello World" to the client. This method allows for the creation of a structured routing system in Go applications, enabling developers to handle different types of requests at specified URL paths with the corresponding functions. By utilizing http.handlefunc, developers can effectively build RESTful APIs, web servers, or other types of services, neatly organizing their codebase and ensuring proper handling of incoming requests. In Go language, the encoding JSON package is utilized to encode and decode JSON data. It allows for seamless conversion between Go data structures and JSON representation. Developers can define Go struct types with struct tags indicating how the fields should be serialized to JSON. This enables easy marshalling and unmarshalling of data without the need for manual JSON parsing. In the provided example, a person struct is defined with name and age fields that have been tagged for JSON serialization. An HTTP handler named personHandler is created to handle requests to the /person endpoint. Inside this handler, a person struct is instantiated with sample data, name Alice and age 30, and then encoded to JSON using json.newEncoder W. Encode person, where W is the response writer. Upon invoking this handler, the person struct is automatically encoded into JSON format and sent as the response to the client making the HTTP request. This simplifies the process of handling JSON data in web applications, offering a convenient way to serialize and deserialize data structures. This method of JSON encoding and decoding is commonly used in web development for processing API requests and responses, facilitating seamless communication between server and client-side applications. It streamlines data exchange in a format that is easy for both humans and machines to read and interpret, promoting interoperability between different systems. Building an API in Go is like constructing a Lego set. Each piece of the Lego set represents a function or endpoint in the API. Just like how you carefully assemble each Lego piece to create a finished product, you carefully arrange your functions and endpoints to create a working API in Go. If you make a mistake in assembling the Lego set, the final product might not look right. Similarly, if you make a mistake in coding your API, it might not work properly. Program example. In our Go program, we create separate functions for different tasks such as getting data, updating data, and deleting data. These functions are then assembled together to create the API endpoints for our application. By carefully structuring and testing our code, we ensure that our API functions correctly and serves its purpose effectively. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The above code snippet exemplifies a basic API implementation using Go. 3 distinct functions are defined to respond to different types of requests: a GET request to retrieve data, a PUT request to update data, and a DELETE request to delete data. These functions serve as the core functionalities of our API, akin to individual components of a Lego set that come together to form a larger structure. HTTP routes are established for each operation by utilizing http.handlefunc. This mapping ensures that when a request is made to API-get-data, /APA-update-data, or /delete-data, the corresponding function is invoked to handle the request. Upon initialization, the HTTP server is started on localhost 8, allowing clients to interact with the API. Any incoming requests are directed to the appropriate handler based on the specified endpoint, thus enabling users to interact with the API seamlessly. This structured approach to API development in Go facilitates the creation of a robust and scalable system, much like assembling a Lego set with precision and attention to detail. Each function plays a crucial role in the overall functionality of the API, offering a foundation for expanding and enhancing its capabilities as needed. One industrial application of building APIs with Go can be seen in e-commerce platforms. For instance, a retailer can use Go to create APIs for managing product inventory, processing orders, and handling payments. Each API endpoint can correspond to different functionalities like adding products to the cart, updating shipping information, or processing refunds. Another real-world example is in the field of Internet of Things, IoT devices. Companies developing IoT solutions often use Go to build APIs for collecting sensor data, controlling devices remotely, and implementing machine learning algorithms for data analysis. These APIs enable seamless communication between various IoT devices and centralized servers, facilitating efficient data exchange and processing. Building APIs with Go empowers developers to create scalable, secure, and performant systems that can handle complex interactions and data processing tasks. It provides a robust foundation for developing modern applications that require flexible and reliable communication interfaces. Across the globe, Go's versatility and efficiency in building APIs are being leveraged by industries spanning from e-commerce to IoT, showcasing its adaptability to diverse business needs and technological challenges. Keep learning, stay curious, and I'll catch you in the next video.